In this video, we're going to explain the difference between process capability and process performance, two metrics that can still cause confusion even among senior level process and quality engineers. Since we will be focusing specifically on the differences between these metrics, I'm going to assume you're already familiar with the basics. If you're looking for a more detailed introduction to these metrics and calculations, check out our complete guide video highlighted in the corner. Let's get started. Although both metrics compare process variation against customer specifications, they answer different questions. Cp and Cpk measure process capability using within-subgroup variation, also known as short-term variation. Pp and Ppk measure process performance using overall variation, also known as long-term variation. I know this still feels a bit abstract, so here's a simpler way to think about it. Cp and Cpk ask, what is the process capable of when operating under stable conditions? Pp and Ppk ask, how is the process actually performing over time? That may already sound clearer, but don't worry, everything will make sense as we go through. When we look at the formulas, Cp and Cpk and Pp and Ppk appear almost identical. In fact, the key difference comes down to how the standard deviation, or sigma, is calculated. Process capability metrics use sigma within, and process performance metrics use sigma overall. For a Cp and Cpk study, your measurements should be collected in subgroups. For example, you might take a sample of 5 parts from each production shift over 2 weeks. A common approach is to collect 25 subgroups with 5 samples each, resulting in a total of 125 measurements. The important point is that subgrouping is required for Cp and Cpk calculations. Now let's look at how standard deviation is approached for Cp and Cpk. Factors such as different operators, raw material lots, machine adjustments, or environmental conditions can create variation between subgroups. However, when calculating Cp and Cpk, this between subgroup variation is intentionally ignored. And we do that this way. We estimate sigma using only the variation within each subgroup. We take the average range across the subgroups and convert it into a sigma estimate using the S-bar over C4 method, where S-bar is the average of the standard deviations of the subgroups, provides an estimate of the within-process standard deviation. For small subgroup sizes like 5, the R-bar over D2 method may also be used to estimate sigma within. Notice what's happening here. We're measuring variation within each subgroup while filtering out variation between subgroups. This means that even if the variation between the subgroups changes over time, the calculated Cp and Cpk may remain unchanged as long as the within subgroup variation stays the same. So we're filtering out effects such as operator changes, machine setup adjustments, day shift versus night shift differences, and material lot changes. By removing these sources of long-term variation, we can answer the question, what is the process capable of when operating under stable conditions? And that's it for process capability metrics. If you've understood this part, the process performance metrics will be much easier to understand. For Pp and Ppk, we calculate the standard deviation using all measurements together without separating them into subgroups. This means every source of variation that occurs over time contributes to the sigma calculation. As a result, Pp and Ppk answer the question, how is the process actually performing over time? The calculated variation includes all real-world sources of process variation, such as different shifts, different operators, raw material lot variation, machine setup adjustments, and environmental changes. In other words, process capability measures the potential performance of a stable process, while process performance measures the actual performance experienced in production over time. And that's really the fundamental difference between process capability and process performance. Now I'm going to show you how to calculate Cp, Cpk, Pp, and Ppk using Sigma Desk. The link is also in the description below, and you can sign up for free and follow along. From the Six Sigma Tools menu, I select Capability Analysis. Next, I can either reopen one of my previous studies saved in Sigma Desk or paste a dataset from any source, such as Excel. Let's use the second option. First, I configure the chart settings by entering the specification limit and subgroup size. Then I paste my dataset into the spreadsheet below. I have 125 measurements following a common industry recommendation with 5 measurements collected from each day's production. After pasting the data, Sigma Desk automatically calculates the capability metrics and displays them alongside a clear histogram of the process distribution. Here are the results. As shown in this example, Pp and Ppk are typically lower than Cp and Cpk because they include all sources of variation in the process. In contrast, Cp and Cpk are based on within subgroup variation and therefore exclude variation between subgroups. We can see a higher standard deviation for the overall sigma, which is used to calculate Pp and Ppk. This higher level of variation leads to lower process performance metrics, Pp and Ppk compared to process capability metrics Cp and Cpk, which are based on within subgroup variation. You can also compare Cp and Cpk to evaluate how well your process is centered within the specification limit. In our example, they are quite close to each other because the process is well centered, as you can see on the histogram. Now it's your turn to run capability studies in Sigma Desk. And with that, we've reached the end of the video. If you found this helpful, please don't forget to like and subscribe. It really helps other people find our content. I'll see you in the next one. Goodbye for now.